Hello students, today we are going to study first part in vector integration, that is line integral. Now the definition is any integral which is evaluated along a curve is called a line integral. Now suppose f bar is f1 I bar plus f2 j bar plus f3 k bar and r bar is xi bar plus yj bar plus zk bar. So dr bar must be dxi bar plus dyj bar plus dzk bar. Then line integral is given by integration over curve C f bar dot dr bar equal to integration over C f1 dx plus f2 dy plus f3 dz. Now see the application of that. Line integrals are useful in the calculation of work done by a variable force along paths in space and also rate at which the fluid flows along path and across boundaries. Now, suppose P1 and P2 are the points given, which are initial and terminal point, then work done by the corresponding force is given by W is integration P1 to P2 F bar dot dr bar. Now suppose path joining the 2 points given in the problem it is not mentioned, then this is the technique by which we can solve that problem. We can check that del cross f bar is equal to 0 or not. And suppose the corresponding vector field is irrotational, means del cross f bar we are getting 0, then there exists a scalar potential phi such that f bar is del phi. So in that case, work done can be calculated using this formula, that is integration a to b f bar dot dr bar equal to integration a to b d phi, that is phi b minus phi a. Now next thing is, if f bar is irrotational, then work done by f bar in moving a particle from a to b is independent of path joining a and b and depends only on endpoints. But if f bar is not irrotational, then work done by f bar depends on the path. Now, if work done by irrotational force field of f bar around closed curve is 0, then f bar is said to be conservative force field. Now, let us consider the example of work done. Find work done in moving a particle once round the ellipse. X square upon 16 plus y square upon 4 is 1 and z equal to 0 under the force field given by f bar is 2x minus y plus z I bar plus x plus y minus z square j bar plus 3x minus y plus 4z k bar. Now, we know that work done is given by integration over C f bar dot dr bar. So that is integration over C 2x minus y plus z dx plus x plus y minus z square dy plus 3x minus 2y plus 4z dz. So this is nothing but f1 dx plus f2 dy plus f3 dz. Let it be equation number 1. Now, here the given curve is ellipse. The equation is x square upon 16 plus y square upon 4 is 1 and z equal to 0. If you compare with standard equation of ellipse, then a must be 4 and b must be 2 here. So, since it is ellipse, we can substitute x is 4 cos theta, that is a cos theta. So, dx becomes minus 4 sin theta d theta, and since y is b sin theta, dy becomes 2 cos theta d theta, dz must be 0 since z is 0. Now since the curve is complete ellipse, we can say theta varies from 0 to 2 pi. Now, if we substitute all these values in terms of theta in equation number 1, then 1 becomes work done equal to integration 0 to 2 pi. It is minus 28 sin theta cos theta plus 8 d theta. Now if we solve these integrations, we get 16 pi as work done. Now, this is how if we consider this particular example, then we know that the path is ellipse. So In such problems, we have to convert the example into one variable. Sometimes parameter may be given as t, sometimes in this way by using substitutions in theta, we can convert the problem in theta. So, whenever path is mentioned, we can use this technique to convert the problem into single variable and see the limits of that single variable. Next, we will consider one more example. Suppose this is the second example. Find work done by this force in taking a particle from 111 to 220. Now if you observe, then here path joining these 2 points is not mentioned. Whether it is any line or anything, it is not mentioned. So we can use this technique. Check that del cross f bar is 0 or not. Now if we check for this particular example, then we will get definitely del cross f bar is 0. That is curl f bar here in this case is 0. So the conclusion is f bar is irrotational. And if f bar is irrotational, we know that there exists a scalar potential phi such that del phi is f bar. Now, f bar dot dr bar will be d phi then. So f1 dx plus f2 dy plus f3 dz. Now if we integrate both sides, then integration d phi will be integration of this side completely, f1 dx plus f2 dy plus f3 dz. After integrating, we get x cube upon 3 plus y cube upon 3 plus z cube upon 3 minus xyz. We already studied how to find scalar potential phi. So this is how we are getting phi is x cube by 3 plus y cube by 3 plus z cube by 3 minus xyz. Now we know that work done is integration f bar dot dr bar. But since here path is not mentioned, we will consider integration a to b d phi, that is phi b minus phi a. We have seen the remark just before how it is phi b minus phi a. Now this becomes phi 111 to 220. Now if you put these 2 points respectively, end point and initial point, then we are getting work done is here 16 by 3. Okay, so this is how, if path is not mentioned, we can check that the field is irrotational or not, and if it is irrotational, this is how we can find work done by putting the points given. Okay, thank you.